I'm Patty Simpson with Simpson Math. Let's find some confidence intervals when we're given the margin of error. So first problem says, a hardware manufacturer produces bolts used to assemble various machines. The manufacturer wants to estimate the mean diameter of bolts produced using a simple random sample of 36 bolts. The sample mean is 4.4 millimeters. So we went out, we collected a random sample of 36 bolts, measured the diameter, and found a sample mean that is 4 4/10. If the margin of error for the data using a 95% level of confidence is 4/100, construct a 95% confidence interval for the means of bolts. So here's what we've done. We've found a sample mean. And remember from the central limit theorem that sample mean is part of a sampling distribution. So that sample mean is part of a sampling distribution. And in that sampling distribution, the mean of the sampling distribution should be about the same as the parameter mean, so our entire population mean. And we're trying to find that population mean. So we're going to create this interval where we're going to say, well, we know, based upon what we found, with 95% confidence that the parameter, that population mean, falls between these two numbers. And the way we're going to do that is we're going to take our sample mean, and we're going to add our margin of error to it. And then we're going to take our sample mean and we're going to subtract our margin of error from that sample mean. So we're going to do both of those things. We're going to subtract the margin of error, and we're going to add the margin of error, and that range, we're going to say with 95% confidence that the parameter is within that range. Or if you think about that sampling distribution, what we're doing, our mean that we found, that sample mean, is at 4.4. And then I'm really going out 2 standard deviations because of this 95% confidence interval. Remember with your empirical rule, the probability for 95% is out 2 standard deviations. So I'm really going out 2 standard deviations. And this margin of error tells me that that distance from the mean out 2 standard deviations is 4/100. So I'm just adding that 4/100 to the 4 4/10 to get 4 44/100. Then I'm going to subtract. So I'm going to go back those 2 standard deviations. Well, the margin of error is that distance that is 2 standard deviations. So I'm going to subtract that 4/100 from that 4 4/10, or you could say 4 40/100. Subtract 4 from that and you get 4 36/100. So my confidence interval with 95% confidence is, from 4 36/100 to 4 44/100. And I'm saying with 95% confidence level that the population mean is going to be somewhere between 4 36/100 and 4 44/100. So that's what that confidence interval is once I find this sample mean, I can now, with a certain level of confidence, tell you where the population mean there is. So let's do another example here. A college student researching study habits collects data from a random sample of 250 students on her campus and calculates a sample mean of 15 7/10 hours per week. If the margin of error for her data using a 99.7% level of confidence is 7/10 hours, construct a 99.7% confidence interval for her data. So remember, all we're going to do is take this sample mean and we're just going to subtract our margin of error. And then we're going to take our sample mean and add our margin of error. And that's going to be our confidence interval. So let's go ahead and do that first. So this 15.7 minus my margin of error of 0.7 is going to be the low end of my confidence interval. And then my 15.7 plus that 0.7 is going to be the high end of that confidence interval. So I do the subtraction, I get 15 to 16.4. And she's saying that with 99.7% confidence level, that the population mean is going to be between 15 hours of sleep and 16.4 hours of sleep. So if you think about this mean is part of a sampling distribution. And remember when we've drawn that sampling distribution before, we put that mean here in the middle. Then the margin of error tells me the distance. Well, this one's for 3 standard deviations out. My critical value would have been 3. So 1, 2, 3 out. That margin of error is telling me this distance, which that distance here was 7 tenths. Or maybe I should do it this way. Here, this distance is 7 tenths. I could do the same thing this way, 1, 2, 3 out. That distance is 7 tenths. So we're saying with 99.7% confidence that the parameter mean, that population mean, is going to be between 15 and 16.4, because that mean there is an unbiased estimate. So that's how we can find the confidence interval when we are given the margin of error. Math Made Simple is Simpson Math. Thanks for watching.